Okay, Max is going to talk to us about USB HID drivers using Wacom tablet as an example to train free Bruning. So, without further ado, let's get started.
Okay, I guess I have a few questions. Who writes drivers in here besides Garrett?
If James was here, then I'd say.
And the two who put their hands up, is that Solaris, Linux? Solaris. Linux, oh, so there were three people that put their hands up, okay. Peter, yeah? Solaris, right? Okay, okay. So what I'm going to do is basically go through what I did to get Wacom tablet to work on OpenSolaris. And for those who don't know what a Wacom tablet is, here's one. They make a bunch of them, and so what I'll do is very briefly describe some of the features of the tablet, free advertisement for Wacom. I'll talk a bit about HID devices. This will be very brief also. Then I'm going to look a little bit at how Linux does this, and then I'm going to talk about what Solaris does as far as HID drivers are concerned. And then at the end, I'm going to walk through the 3 iterations I've done so far of the tablet on Solaris. And a few disclaimers. I am not a Linux expert. So if you hear me saying something that isn't correct about Linux, feel free to just say something. And I don't know X either, so I guess that leaves Solaris, which hopefully I know a little bit about. All right. Okay, so there's various tablet models. The ones I have, I've got 3 of them, and they're this or a little larger, but they've also got some with the tablet is actually built into a screen so that there's actually 2 cables coming off the tablet, one for your video and one's USB. The tablet comes with a pen, and the pen has replaceable tips. It's got a side switch, and they've got various other pens that you can use. And the tablet can send proximity events, so when the pen gets close to the tablet, whatever close is, it will, the tablet sends an event, sends data to the system saying there's a pen close to it, and it actually, some of the pens have serial numbers in them so that you can keep track of who's been touching the machine, or at least which serial number's touching the machine. The tablet sends absolute pen coordinates. It keeps track of pressure, height, how far above the tablet the pen is, tilt, what's the angle of the pen, and the tablet also has these buttons that you can do various things with, if you've got driver software to handle all of this, of course. The tablet has a HID boot protocol. For those who don't know what this is, I'll get into it, but only very briefly. But basically, when the tablet's plugged in, it says, I'm a mouse. Okay, and what that means is that instead of the pen tracking, if I put the pen on the upper right-hand corner of the tablet, if the tablet is in pen mode, the cursor, the pointer on my screen should appear up in the upper right-hand corner. But if it's a mouse, the actions of the pen are different. So you put the pen down on the screen in a particular place, and the pointer on the screen doesn't move. So it acts more like a mouse. And one of the things to get the driver to work is basically to get the tablet into pen mode. Yeah. Well, the tablet works fine as a mouse, but then why bother? All right, so let's see. Let's try that. Okay, so as far as HID is concerned, HID is, for those who have no clue what I'm talking about, it's human interface device, and this is basically mouse, keyboards, joysticks, throttles, and there's a few other devices that are kind of They call them HID devices, but even though they don't necessarily interact with humans. So some power management devices are considered HID devices. And the way a HID device and a HID driver communicate are through these things called device descriptors and or data. And the device descriptor is broken down into configuration descriptor, interface descriptors, and then endpoint descriptors. Basically, to talk to the tablet, you talk to an endpoint descriptor. You can use MDB or PRT Pickle to look at descriptors, and because I really like MDB a lot and I use it all the time, I'll show you some of what this looks like. So this is basically just printing out USB information for my laptop, and the tablet is the 7th entry there. It's a HID device, and notice it says it's a mouse because the boot protocol, again, identifies the tablet as a mouse, and MTE 450 is the model number for this particular Wacom tablet. And if you wanted to look at the descriptors and see what's there, there's another MDB command you can run. So you specify the slot number from the previous output. Slot number 7 was the mouse, actually the tablet, and the -V gives you various descriptor information. It turns out that everything that's in here is defined in USB documentation. And there's actually a header file, or actually a couple of different header files in Solaris which use exactly the same names as what's described in the USB documentation for HID. So, so you can see the vendor and product ID. This is Wacom's vendor ID is 56A, and the Bamboo, which is this tablet, is product ID 65. But we go on. Here's a configuration descriptor, and again, more information about the tablet. That attributes value is hex 80 basically says that the tablet is powered by the bus. It's not using an external power supply. And the maximum power is in units of 2 milliamps. So 16 would be, 22 decimal or 44 milliamps is the maximum power this guy takes. Then you have hanging off the configuration descriptor and interface descriptor. Value of 3 for interface class identifies it as a HID device. It supports boot protocol, and the boot protocol it supports is for mouse. That's the value of 2. So all of this stuff is actually in the USB documentation. We go on. Okay, so anything else that's of interest here? No, I'm just showing you that you can get the information for a USB device, no driver at all. It'll give you this information using MDB. PRT Pickle does give you the same information, although it won't give you the nice names of all the structures. So for a lot of the fields, you'll just get a bunch of hex byte values. So I kind of like this a little bit better. But okay, so on Linux, you can do the same thing. USB device information is in /proc. This information is ASCII. You can cat it out, and there is a command. I'm not sure it's available with all Linuxes, lsusb -vvv, which will show you descriptors as well as these things called HID usage tables. The MDB thing that I just had up here with the -T option, you can get HID usage tables. Supposedly, if you very carefully read the HID usage table, you can figure out everything you need to know to write the driver. Supposedly. I'm in the Brain Institute, and hopefully I can pick something up here, but I haven't been able to do it. No, it won't tell you the commands you need to send to...
Generally need to write some of the drivers.
Yeah, okay. All right, so USB HID on Linux. Drivers on Linux for HID, basically there's a couple ways you can implement them. One is you have a kernel driver communicating with the host controller via this USB-core API. So you write your driver to handle the particular device, and to talk to the device, you have to talk actually to the host controller, and there is an API for doing that USB-core. And there's actually a programming guide for some of this stuff, but what I found in general with learning this stuff on Linux is that, you Google for the information and you get whatever 20,000 hits, and 19,999 of them are for previous versions. At least that's my impression. So the real way to do it is, as someone mentioned this morning with the database talk, is you have to look at the code. There is, in the code, there is the kernel documentation, and that actually is reasonably up to date. The second way to do it, so one way is you write a kernel driver. A second way to do it is you write a user-level driver that communicates with a kernel module called HID-input. You could also write a user-level driver that communicates with something called HID-dev. So HID-input is basically meant for things like mouse, keyboards, joysticks, that sort of thing. HID-dev would be more for things like power supplies, USB power supplies. And both of these, again, communicate with the actual host controller to talk to the USB bus over using an API, this time called HID-core, which is very analogous to the USB core stuff. You can also write user-level drivers using libusb and/or libhid. The Wacom implementation on Linux, there is a kernel module that communicates directly with the host controller via USB core. So for all practical purposes, on Linux, the Wacom driver is not implemented as a HID device. And there are some comments in the code that there's one comment that just says, Wacom isn't really a HID device, although it says it is. I don't know what that means, but okay. It doesn't use any of the HID mechanisms that are inside of Linux. What you do with Wacom on Linux is an application will open and use something called the input device, and basically what you get from the input device are what are called input events. And let's take a closer look at this. So on Solaris, HID devices, there is a driver in the kernel called the HID driver. There's a manual page for it. The HID driver is a streams driver. So if you wanted to talk with the HID driver, you would write a streams module. All right, and actually that's what I do in this, although it turns out there may be a fourth way to do it, but I haven't bothered to look into that, which doesn't use HID at all. But right now I've written actually 3 different versions of a streams module that allows me to talk with Wacom, and I'll get into that shortly. So HID is a streams device. Individual HID devices use a streams module pushed onto the driver to handle the specific device. And this second to last point here, there is no documentation for writing such a module. And I guess the good part of that is that they can change things, and they do. So I had a version of my driver which worked fine on my laptop, and I sent it to a client, and it promptly crashed the machine because they changed the way that you send reports. So there was a version of Nevada. This is fairly early on, so this is over 2 years ago that I started, almost 3 years ago that I started doing work with this. And the version of Nevada at that time, to send reports to HID, you basically put the report information into a streams message. Well, they changed it so that they don't use the streams message for that. You just send it data. But my version, of course, based on what I had, was sending streams messages, and it went to the customer, and because it wasn't a streams message anymore, it blew up because it indirected through a bad pointer. There is a kernel module called a HID parser that handles parsing, and all the report and descriptor stuff is handled by this HID parser. And if I can avoid it, I'm not going to talk about it anymore. Is this water? What do you think?
No, it's not vodka.
It's not vodka. Oh. It's gin. It's brain juice. Okay. Great. All right. Now, okay, so also on Solaris, there is libUSB, which is analogous to what Linux has for basically for writing drivers at user level, and this uses something called the UGen driver to communicate with the host adapter. And this, by the way, is the way I have not tried with Wacom, although it should work. I'd have to figure out what I need to do to make the particular Wacom device show up as being driven by UGen, and I think that's fairly straightforward. Peter, go ahead. I'm sorry? USB claim. Yeah, I recently decided to take a look at this, but right now the stuff is working. And yeah. Well, I'll get into what I ended up doing, but I may end up going that route in the end.
I think the problem that you run into where USB claim doesn't work is that the HID driver is binding to the device. So normally UGen will bind to a device where there's no bind, where the operating system doesn't know about it, but the HID will by default bind the device. You can put in a different binding for it using updates or whatever.
Right. That's what I think I have to do. And I don't know if everyone got that, but what Garrett was saying was that basically because the device is acting as a HID device, that the HID driver gets bound in, and basically you have to change that. So what you do is basically update DRV on the particular device that was the tablet to change it to be using UGen instead of HID. But I haven't done that. As far as OpenSolaris is concerned, there's no libdev equivalent as there to what's on Linux, and Solaris does not have an input event module, at least not right now. I actually talked with some people in Sun, China, it's over a year ago, and they said that they were working on something like this, but I don't know what's happened with that. So there are right now streams modules for supporting mouse, keyboard, and for audio control, which this is basically read demand, RTFM for HID, and it'll tell you that it's their modules can be written for these three types of devices. We go on. Okay, so a little bit more information about what Linux does. Okay, so application opens, reads an input device, dev input, event some number, and basically what I'm doing here is showing you more or less what Wacom does on Linux. So, but it's supposed to be generic. There is an event handler module in the kernel that basically gets input events from the input module and passes them to whoever is registered for the event, normally the X server. And the input module basically it gets events from drivers. So a driver, for instance, a Wacom driver would register with the input module through some simple API, and then the driver picks up the data from the tablet, converts it into input events, calls into the input module. The input module says, okay, who's waiting for these events? And it sends the events to whoever's waiting for it, typically the X server. And what kind of events? Well, button press, for instance. This input module is it tries to be very general, so there are probably a couple hundred different events that it handles. X, Y position, Z position, pressure, tilt, and 200 and something buttons for those of you who have devices which have 250 different buttons. And okay, so it's meant to be very generic, and actually I think does a reasonable job at being generic. Some code, and this is, I'm not going to show much code in here. So this is for, of course, the foo device on Linux. And what do I want to, is there anything in here that I really want to point out? So there is an API for talking with USB devices on Linux. And you can see some of it in here, the USB buffer alloc, USB alloc URB, and then down near the bottom, fill int URB. And the idea is that basically we're going to receive on the interrupt pipe data, and whenever we receive data on the interrupt pipe, a routine foo_bar IRQ is going to get called. So when foo_bar IRQ runs, it basically is getting passed in data that's coming from the particular device. And then foo_bar IRB does whatever the heck it wants to do. Now, this particular little bit of example code, it registers with the input device, so that the idea is down at the end, the input register device call. So the idea is that whenever foo_bar IRQ gets called, it takes the data that's passed into it, forms it into events, and then makes calls into the input device module. And so here that is. So basically we, just as a very simple example, let's say that the piece of data that we're picking up is an absolute position, and we call into the input device module, and we specify a type, which would be basically this is an absolute position, a code which would say this is the X position, or this is the Y position, or whatever, and a value, which would basically be what the actual position is. Where are you on the tablet? All right, so we move on. Okay, so a little bit more on input device handling and the input module. So yeah, each input device module maintains a set of bit field arrays of capabilities of the underlying device. So the driver says, okay, this device, this is not the input driver, but the actual, for instance, Wacom driver, says this device can handle X and Y positions, absolute positions. It can do pen tilt, X and Y tilt. It can do pressure. It can do various buttons. And it tells the driver tells the input module about the different events that it can handle. And then basically, whenever data comes in from the device, the driver takes the data and figures out what events I need to generate and sends it to the input device. And the input device says, okay, who's waiting for these events? Oh, this guy up here, the X server, basically. And it sends it up to there where they do whatever the heck they want to do with the information. All right. Yes, this again is more about how Linux does this with Wacom. So the Linux, well, really, do I do this here? Yeah, so this is what I'd like to look at for just a minute. So on Linux, user-level code typically is implemented in a library that you would somehow get the X server to load. And the library will typically, well, actually there's a how-to on how to do this, but you typically have a function in the library which at the end sits there reading packets from the device. And every time it gets a packet, maybe the packet just says, this is the X position. Well, I don't really have enough to move the mouse yet, to move the cursor. Then I get the Y position. Okay, now I've got enough to move the mouse. Or this is a button click, and which button was clicked or released, and et cetera. So we basically gather up packets until we've got enough information to send events, and then we call XF86 post whatever event. So we go on. Okay, on OpenSolaris. So this picture shows a system that has one mouse, which happens to be USB, and one keyboard, which also happened to be USB. And applications, basically, they open up dev mouse and they get a upper level stream to the cons mouse multiplexer. So if I had a second, let's say, USB mouse, I would have another box with another USB MS underneath the cons mouse streams multiplexer. And in fact, if I was using, on my system, I've got an i8042 built-in mouse. That's not USB. That mouse is also underneath the cons MS streams multiplexer. So it looks a little like, wait, how do I do this? Is this going to work? Of course not, you're right. Which one is it? Which window do I want here? That one isn't it. That one isn't it. That one. No, that's the one I want. So let's see if I can draw this. So here's, hello? Oh. That's not what I wanted to do. Let's try you. So here's the app. Is this working? Yeah, it sort of is. Okay, here is the stream head stuff, a cons mouse. I'll leave out the, and then here, for instance, is, what is some, well, I don't remember the name of the module off the top of my head, but here is the i8042 device, and there is a module here whose name I forget, but it's some mouse module. What is it? It's mouse 8042, thanks. And then underneath this, you might have USB MS, and underneath this, a USB mouse, HID. Okay? So other HID device, other mice would plug in under cons MS. And the application just opens up dev mouse and they in effect get all the mice. Which is, well, yeah, you're only going to have one pointer on the screen. So whoever we read last is going to win as far as the position of the mouse, the pointer is concerned. All right. It does sort of work. Okay, good. Let's go back to this stuff. Okay, so we go on. Okay, so Linux, whoops, I went the wrong way. Okay, so what did I do? Well, I ended up writing 3 different versions, and I'll explain why and what I did. The first version I wrote was to get to work with Wacom. I had a client who basically said, we want to use Wacom with Solaris, and we don't need to use any of the button keys. We only want to do absolute pen position, and we want to do pressure. We want to know about pressure as far as if you press hard enough, we want that to be sent as a button press. They also wanted to use the side switches, and they wanted to use the eraser end also to send events, both the stylus end and the eraser end of the pen. But they didn't care about button presses on the tablet itself. They didn't care about tilt, any of that stuff. So the first version I wrote was basically to take the USB MS module, and I modified it so that it could handle normal USB mice and it could handle the tablet. Now, why did I do that? There's a couple reasons. One is I didn't know X, and I didn't want to learn X in the amount of time I had. Okay? So yeah, it's a stupid reason, but okay. There was another reason which it turned out wasn't really a reason. Another reason was that I couldn't figure out how to get USB-MS out of the way. In other words, because of the boot protocol, the system was setting up the USB-MS module, and there's no way for me to pop it. I don't have access to it. I'm going to talk a little bit more about that in a few minutes. So that was the first version. And this version actually has been in production for about 2 years. There's a particular airport, and if you fly into it in Europe, they're using this to, I don't know, doodle while they tell the planes what. No, they use it to, they keep track of where the planes are in the sky above, in the area around the airport, and then they can press on one of the planes and it pulls up information, and then they can tell them, turn right quick because there's another plane here or whatever. So actually, we extended it to work with TwinView, I think it is. But everything I did in this particular version is done in the driver itself. So in other words, at user level, there's basically the normal mouse handler, and that's it. There's nothing I wrote at user level for this. Actually, there's a configuration program that I wrote at user level that sent ioctls down to my module so that they can adjust how much do you press and that sort of thing. But it's all done in the module. So I did this a while ago, and then I thought, you know, this can't be the right way to do this. I'm sure Linux doesn't do it this way. I mean, this just doesn't make sense. I'm not sending events. How the heck do you use this stuff with GIMP? And my module, GIMP would do absolute pen positioning, but you wouldn't be able to press down and make the ink bleed on the screen and that kind of thing. So I said, you know, I really want to do this with X. So I said, how can I do this? And what's the easy way? And the easy way, for me at least, was to write a Wacom module from scratch, a kernel module that basically did what Linux did as far as input events are concerned. So what the module did was it would get the data from the tablet, it would form the input event structure that Linux expects, and then it would send it up to the Wacom Linux library code. And this worked really well. But there's a third iteration, and I'll come back to why I didn't keep with the second iteration, but that will wait a little bit because the argument or the discussion that may occur at the end, we're going to hold off for just a few minutes. The third way I did this was, yeah, never mind if you didn't get that, we'll get there. The third way is basically and this way actually, maybe I like this the best. What I did was I said, screw all that, why am I doing all this? Linux actually, if you look at it, the Wacom driver in the kernel does all this parsing of the data to form these events, and then it sends it up to a library, a Wacom library, which takes the events and does all this processing to send it to applications. We're doing the processing twice. Well, look, I don't think it's an efficiency issue. I think that this input event device, if it's general enough, you shouldn't need to have a Wacom library and a foobar library. You should have one library that picks up the events of whatever the heck it is and does everything. And then it would make sense. But to me, well, why do I'm doing it in two places. I'm doing it in the kernel and I'm doing it at user level. So what I did was I said, screw this. In the kernel, all I'm going to do is put the tablet in the pen mode and send up raw data. And then I change the X library so that it picks up the raw data, parses it, and passes the events out, which to me makes the most sense. But let's a little bit more on this. Okay, so again, here is a picture with maybe my modified USB mouse, and you'll notice it's this, I'm using the same code for a real mouse, for a normal mouse, and for the tablet. Not that interesting, but it's been in production and it's working. I flew into this airport. I went to see them about something, and I happened to ask them, so after I got there, are you guys using this? Oh, yeah. Oh, great. I guess it's working. I'm here still, yeah. All right. Problem with the first solution. Okay, I couldn't find a way to pop the USB MS module. Well, it turns out about a year and a half later, after I did this, I was starting to play around with it, and I happened to open the underlying HID device. The module's gone. All I had to do, I didn't realize, I spent a lot of time trying to figure out how to get around this stupid dacf.conf stuff. If you ever want to give yourself a nice headache, remove this file. And then reboot your system.
If you have a serial port.
Yeah, make sure you have a serial port, but that won't help you, I think. Because this actually controls the module that gets pushed on the serial port as well. It's not just USB. So lots of fun here. It's very secure, no users, and actually the security discussion yesterday, it says the security is as good as the people who are using it. So you want your system secure, put it in a room where no one can get in, and you have no internet connectivity, and it's secure. Okay. All right. Okay, and so there was no tablet key support. There was also on Spark this thing called HWC. So I've got the driver working fine on my x86, my laptop, and I send it to the airport, the air traffic control guys, and they say, it doesn't, the pointer is constantly flickering. It doesn't really track very well. I couldn't figure out what the heck's going on. And then somebody in Sun actually said, oh, it's Spark. Try moving the HWC module out of the way. This is hardware cursor control, and it fixed the problem. I'm not sure what HWC is supposed to do, but it was not working very nicely with my, my driver. Okay, so we go on. Okay, so the second way is, again, I implement the Linux input events within a module. And it turns out that the USB module, the USB MS module was automatically popped when I just opened the underlying device. So this thing that I spent like a year and a half kept thinking, how can I do this? It wasn't a problem. All right. The nice thing about doing it this way is that the only modification I needed to do in the X server library was about 10 lines of code that basically instead of opening up dev input event number, it opened up the mouse, the underlying device, and I think did some ioctl to get back product and vendor ID, and everything else was unchanged. Fabulous, really easy. And everything worked, and it worked on different tablets. I've got 3 different tablets, and I've had a couple people try the code on tablets that I don't have, and it's all working. But there's a problem with this. First problem I already mentioned. The Linux is doing this stuff twice. It's handling it in the driver, and it's handling it up at the X server. The second problem, it says licensing, but we aren't going to talk about that.
Oh, come on.
No, we're okay here? We don't need to talk about licensing here?
So how did you work around the licensing?
I haven't worked around the licensing problem. Actually, the third iteration is an attempt to work around the licensing problem. The licensing problem is, I started to ask around on OpenSolaris. I said, this is coming along. I'd like to get this into OpenSolaris. And I was told that OpenSolaris's Xorg has some closed bits. The Wacom library module on Linux is GPL, and they can't be combined. And then I was also told, among other things, that I shouldn't be asking questions about licensing on a news group. I should contact a lawyer. And whenever I think contacting a lawyer, I just think, here, just take my money. So I don't contact lawyers. I'm just me. I'm not Sun Microsystems. I'm not, I don't have money to pay a lawyer to go find out that I can't do this, or that, oh, we have enough money that we can take care of it. Don't worry. I know better. So basically, I said, no, I'm not going to do it this way. And that's when I went to the third solution. And the third solution, basically, I do the processing all in the X library. This solution is still being worked on. It works. I've redesigned how Linux's library works, but there's a lot of low-level code that I haven't changed. So it's still got Linux in it. Okay? And some of the stuff I'm not sure how to change. I mean, there's some low-level math functions. So how do you make them separate from Linux's math functions? Oh, so instead of A plus B, you make it B plus A. Don't know, but so I'm still using some Linux library code, so I haven't given this to OpenSolaris yet. And you know, I have thought about that, and no, I haven't. It's actually something I should do.
But RMS is the GPL is the thing.
Well, it is. It's Solaris can switch, but until Solaris fixes that.
Look, I don't want to, this is the pissing war that I love to hear when I'm reading my email, you know, on the mailing list, and I've got plenty of time to just sit and piss around with this.
Because that's.
Didn't you feel if you only do it once?
Yeah. We're not going to go anywhere with the discussion on licensing. Yes, whoops, that was not the way I wanted to go. Okay, so here a little bit of code, but not really enough to do anything with. So what I'm going to do now is, are there questions? Comments? Yes? Okay, so Wacom for, I think there's one for FreeBSD, but it's nowhere near finished. And yeah, eventually I could probably use that, but I don't, you know, I looked at that a while back and decided, no, this isn't ready. Others, yes? I'm sorry? Yes, yeah, I have a larger Wacom that has a mouse and it works great.
And did you think about multiple cursors on screen?
No, I've not. I mean, there's a bunch of work that you have to have an xorg.conf file to use this right now, and apparently I shouldn't need that. So there's a lot of little things that I will still have to change.
It's
But
the multi-pointer X work that's going on.
yeah,
So that's probably a precursor before any.
yeah, I'll wait on that. Go ahead.
So how does GIMP get the information? Does it know about the Wacom?
Well, GIMP, actually, you can tell GIMP to go and learn about the extended input devices, and my xorg.conf has a stylus, a eraser, a pad, and I think a cursor, I think, device. Specifically, they're using the Wacom device underneath. So that's how GIMP works with it. Other questions? Can you get it? Send me email. And don't count on getting source until I've got the Linux stuff squared away. Garrett?
So one of the things it seems like to me, I'm pretty sure that there are people working on this, is full support for the HID report protocol.
Yeah.
All the way up through X. I
Yeah,
don't know, I haven't looked at your code, and obviously I don't look at Wacom specs, but if we try a full HID report protocol implementation, would we need a Wacom driver?
Actually, what Garrett asks is a good question, and it's actually something I've recently looked into. Right now, the way that you tell HID, the HID driver, the way you send a report, for instance, to the HID driver to say, put this into pen mode, is you send an MCTL message. The HID driver doesn't accept ioctals, so you can't do it from user level. This is the only reason I've got any kernel code at all, is I have to put it into pen mode, and to do that I have to use MCTL. It's possible I can do with libUSB and UGen, but I haven't really looked into that. And The full support, yeah, that if there was a way, a user-level API for me to talk specifically to HID, then yeah, I wouldn't need the kernel module either.
So it sounds like this is something that maybe should be looked at as something that should be added,
Yeah.
you know, to the HID.
Yeah, I've actually talked with, I think, Strony Zhang, and, yeah.
I would suggest including me in those conversations.
Okay, that's fair enough.
I can see uses for that, for this semantics code that I've got.
Okay, good. Anyone else? Great. Thanks.